Good morning, good afternoon, or good evening, depending on where you are in the world. And thank you for joining this Cloud Native Now Roundtable. My name is Cody, and welcome back to Techstrong Learning. Before we dive into things, I have just a couple of notes to review with everyone. First of all, we are recording our conversation today. So if you happen to miss anything that we discuss, if you'd like to watch again later, or if you'd like to share this with the rest of your team, we'll be sure to send you the email recording as soon as we wrap up our live session today. Now, if you'd like to get engaged, there are a couple ways to work with us here. You can use that chat tab on the right side of the screen. And when you find that chat tab, I'd like you to let us know from where in the world you're tuning in today. So far, I've seen 5 continents, and I'm waiting on Australia and Antarctica, so I won't hold out too much hope for the last one. Now, if you have specific questions, we do want you to submit those questions to the Q&A tab. We'll be doing our best to monitor both the chat and the Q&A, but the Q&A just helps us prioritize a little bit, and so be sure to send those in as you have them, and we'll do our best to mix them into our conversation. Finally, we will be selecting 2 of our most engaged attendees to win a $50 Amazon gift card. So ways to be eligible are to send in your chats, your questions, and to fill out our post-webinar survey. There's a link in the handouts, but we'll touch on that again before we close out. I'll also remind everyone that in the handout section, there are a couple of resources there for you. So feel free to grab those before we close things out. Those are some good resources for you. So our topic of discussion today is Kubernetes security. And I'm joined today by Cindy Blake, VP of Marketing at Firefly. We're also joined by Alex Feigenson, Senior Manager of Security Engineering at Tenable. We're joined by Robert Brennan, Vice President of Product Development at Fairwinds. And keeping this conversation on the tracks today is our very own Mike Vizard, Chief Content Officer at Techstrong Group. So Cindy, Alex, and Robert, it's a pleasure to have you here on Techstrong Learning with us. Mike, do you want to open up the program for us?
Sure. It just occurs to me that we're always asking everybody else where they're from, so I'm going to actually share that information. I'm in Boca Raton, and our attendees are from all over, and sure they can drop in where they're from if they're so inclined. But I kind of want to get started with where are we with Kubernetes security? In my sense of things, we're seeing a lot more of these clusters show up in production environments, and every other conversation I've ever seen about security when it comes to Kubernetes has always been a little more on the theoretical side. But now we have some hands-on real-world experience with what's going on. So let's start with Robert. What is the current state of Kubernetes security, and are we actually seeing the bad guys discover these clusters and target them?
Yeah, so I would say, so for folks who aren't familiar, Kubernetes is a container orchestration framework, right? You throw Docker containers at it, and it handles everything from scaling to bin packing on, the actual machines that are going to run these workloads, to provisioning things like memory, CPU, disk, stuff like that. There's really 2 main attack vectors for Kubernetes. One is at the control plane level, so folks getting access to basically modify the Kubernetes cluster, run new workloads in that cluster, look at the workloads that are running there, look at any secrets that are in that cluster. So that's kind of the front door into the Kubernetes cluster is through the control plane. And then the second attack vector is really through the application. So if you've got a vulnerable application running in Kubernetes, somebody manages to get inside that application, maybe get to a command line through that application, through some kind of injection. That's kind of the second route into the cluster is through a vulnerable container that's running inside the cluster. So those are really the 2 main attack vectors. The at the application level, we've always kind of had those types of issues. So Kubernetes is really just the new host for those issues. And if somebody manages to get through an application, hypothetically, Kubernetes is designed in a way where they're really locked into that one application, that one container, and shouldn't be able to escape. But there are kind of system level bugs or vulnerabilities or misconfigurations that could allow that attacker to escalate and spread their attack throughout the cluster and attack other applications that are running in the same cluster. And then at the control plane level, we do see misconfigurations and bugs. Most recently, GKE had a pretty large bug that would allow people to basically get access to a cluster's control plane through some poor role-based access control bindings. And so really both are security concerns for anybody running a Kubernetes cluster.
Yeah, I would add to that. I mean, totally 100% right there. I would say it's interesting because I think a lot of the stuff that I see is kind of the same old, same old. I've been doing Kubernetes for, I don't know, 5 years now, and I look at all these attacks, and a lot of them are just like, is it a vulnerable container? Like, is RBAC overly permissive? And these aren't necessarily new concepts. It's how they're enforced and where you enforce them that might be new. But it is kind of interesting to see it. Like, another real classic one is you had mentioned like misconfigured clusters. People that, to make things easy will have like anonymous access turned on to a role that's been assigned that has access to do things in their cluster that anybody can bind to across the internet. And like they do it kind of innocently because, hey, it's to speed up deployment, or a dev turns into prod, and then all of a sudden you're having a bad day. And so I think the other thing that's interesting is there are some hacks out there, like the Silent Bob stuff that was happening, or maybe still happening, where like there's a malicious Docker container that gets published that somebody runs that opens the door up to other things. And that's not just vulnerable, it's vulnerable by design. And I think we're seeing that where once you get into a cluster, you can start moving laterally, and then sky's the limit at that point.
Yeah.
Cindy, do you want to add anything here? Are you seeing anything that's different, or are we just kind of repeating history here and it's the same variations on a theme?
Well, I think anything that can be configured can be misconfigured, whether it's intentional or unintentional. You can have mistakes, and mistakes get replicated. So every time you reuse that infrastructure, if you've got a vulnerability in it, or you've got something that is not necessarily a best practice, and it gets copied, now you've just increased the footprint of that blast radius. So understanding what you have and being alert to misconfigurations is super important for managing those misconfigurations.
Alex, would you say that it's easier to misconfigure Kubernetes than other platforms that are out there? Because one of the things I always hear is that it's complex.
Yeah, no, I think that's a super good question. Like the answer is that I don't necessarily think that any system has has enough same defaults to suit everything. Like like everything has a default. Like, for example, if I got and use, for example, I'm writing some Terraform right now to do some Kubernetes stuff. If I use Terraform to provision a Kubernetes cluster, and I'm not implicitly setting things, I can inadvertently back myself into a corner. And I think that's what Cindy's saying. But every product has that. It's like, for a long time, storage buckets were open publicly by default. It took everybody a while to kind of figure out, hey, maybe that's not a good idea. And so I don't think it's any better or worse. I think in a lot of ways it's actually maybe better because maybe it's the footprint is as wide, but that speaking towards core Kubernetes resources and functions, I think there's another side of this where once you start adding additional capability into Kubernetes clusters, you open yourself even wider and wider to problems. And so, once you start adding other products, you open up other APIs that may be vulnerable, or whatever. And so, I don't know if that really answers it, but I'm kind of 50-50 on it.
Yeah. It's such a large, extensible platform that it's, if you're doing it very vanilla, using some kind of batteries included framework, like, you're probably going to be okay. But, any real world environment, any real world company that has like, actual use cases and is far along their journey, they're going to need to customize their Kubernetes setup. They're going to need to customize how it scales, how it does a bunch of different things, customize their CI/CD pipelines. Kind of the more you customize it and the more you take advantage of like the wide set of features it provides, the more chance there is to mess something up.
Yeah, 1000%. It's the cloud provided, the CSP provider, cloud provided Kubernetes clusters come with a lot of that infrastructure. That's one of the nice things about it. Hey, I've got a load balancer on demand, or I've got, persistent storage. But especially when you're doing roll your own Kubernetes, where you have to make a lot of architectural choices. How am I going to handle backups? How am I handling storage? How am I handling load balancing, exposing the internet? How am I handling all the, once you start extending it, it just adds more complexity to secure 100%.
Mm-hmm. Cindy, should we just buckle up here? Because I feel like we're discovering more vulnerabilities in Kubernetes because we're running them more in production environments, and researchers are coming around and poking at this stuff, and things that we never thought of, or there's more eyes on it now than ever. And of course, the minute a vulnerability gets shared, the most avid reader of that is probably a cyber criminal. So should we kind of just be prepared for a bumpy time ahead?
I think when we think about the future, we really need to get at the root of the issue. And it's really around governance and solid management principles and practices. I think, we tend to try things, and maybe we're a little sloppy when we try things. And lots of times we don't go back and look at the governance processes around it and make sure that that we're following best practices. And so understanding what you have, who has access to it. I think to your point about, are we surfacing more vulnerabilities? We probably are. I mean, from my time at GitLab, I could tell you when I started there, we didn't even have container scanning. And, when I left, it was pretty mainstream. And as you scan, you're going to find things. It's you could stick your head in the sand and say, I don't want to scan. I don't want to know what I have. But I think, as scanning becomes more popular, people understand what they have, maybe from a container standpoint, but they might be missing that broader picture of, if you aren't locking down your configurations, your access controls, your drift, so that, for preventing changes that are unauthorized, then you're really only addressing a small part of the picture. So it really comes down to good practices, and that's a harder thing to do. It's a little bit like diet and exercise, right? Everybody knows they need to do it, but actually taking those steps can be more challenging. And people are starting to come around and realize that.
Robert, are there actually more attacks, or is this kind of like the Coast Guard and drug interdiction? The more boats I put out there, the more I discover that there is a problem.
Yeah, I think that's exactly it. I mean, security is never a solved problem, right? The everything we're building is complex. We're always kind of at the edge of what we're capable of, and so the attackers escalate by one level, and then the defenses have to escalate by one level. We find a new way to block a bunch of attacks, and the attackers get creative and find a new interesting way to attack. So I don't think Kubernetes is like more susceptible to this. I think it's actually a much safer system than kind of a lot of the older school systems, because it gives you so many tools to really isolate workloads and keep one vulnerable workload from suddenly exposing your whole organization. So I think the Kubernetes world is actually a lot better. But I think, you're right, as it gets more usage, as more people adopt it, there's more value, sitting inside of Kubernetes clusters. So attackers are more interested in figuring out ways to attack Kubernetes clusters.
Well, and also I think it's interesting. So the question about like vulnerable containers, I think vulnerable containers are vulnerable containers. Like, they've been around for a long time before Kubernetes existed. And they're not vulnerable because they're containers. They're vulnerable because the software that's running on them is vulnerable. Right. You would run into the same problem on premise in a cloud instance or whatever. But with millions and millions of containers out there, it's important to understand your supply chain to make sure that you're scanning before you let things run. But I mean, there are also container breakout attacks that have happened, which means like, hey, I'm running a container. Can I break out and actually get to the host that's running it? And that's actually happened with, there's like a leaky vessel attack that happened, or it was recently with not to get super in depth, but like there was basically the container runner lets you break out into the host operating system and execute commands. And I think that is kind of unique to running containers. And those ones get really scary in my opinion, because once you get to the host, then you can in theory own everything. But I mean, a vulnerability is a vulnerability. I mean, I work for Tenable. We that's all we do is vulnerabilities. So not all we do, but that's our bread and butter.
Robert, what are we supposed to do about all this? And we talked about the fact that the platform can be misconfigured probably very easily. And Alex mentioned that a lot of that comes down to the default settings, which were not really designed with security in mind in the first place. But if I'm a IT organization, what am I supposed to do about all this? Do I put some adult supervision in there and some controls and a platform engineering team, or do I just say to the developers and basically slap their hands and say, get away from that thing?
Yeah. So one of the nice things about Kubernetes and kind of like modern DevOps practices is that pretty much everything is in infrastructure as code, and it's configured in a way that's like very consistent from platform to platform. So instead of clicking around inside of the AWS console or just running commands manually on a bunch of different servers, you've got Terraform, you've got Kubernetes configuration, you've got YAML and Helm charts and things like that. And so it's really easy. It's much easier now to kind of audit that and say, is this S3 bucket, open to the cloud, or, is this RBAC configuration way too permissive? Is this container running as root? Things like that. It's easy to analyze the infrastructure as code and check that out, or to hit the Kubernetes API and check that out. And so you can start putting policies in place that say, like, we're never going to run containers as root except for like these 3 exceptions. You can say we're going to scan every single container that runs in our clusters and make sure they don't have any critical vulnerabilities. So you can start, really putting policy in place because everything is so nicely codified. I think that's much better that we can put policy, in a codified way. We can actually check it as code rather than just saying to your engineers you're not allowed to run things as root and trusting that they follow those instructions.
Well,
I think the automation is really key, and that policies as code in an automated fashion is the only way to really scale that.
Yeah, and I think putting everybody in charge of that is important. It's not on IT or infrastructure or the infrastructure teams or even the developers to understand the full depth of what it takes to secure this stuff. It's got to be everybody wearing that hat. Because the app owners might understand how to fix the vulnerability, but they're not going to understand what compliance standard they've got to be compliant with. As an example, or the the Kubernetes infrastructure and architecture team have to build the capability for the application developers to be able to use it, and they have to teach them how to do it, and kind of a bit of vice versa. I mean, I think ultimately, fixing vulnerabilities, cutting down on kind of lateral access. So like once you get in, making sure that they can't hop, locking down container registries is another great one. So, and we see this a lot where there's a kind of the company's container registry that stores all their vetted containers, and then you can still pull from Docker Hub. That kind of kills the whole thing, because now you can pull down a vulnerable container that wasn't vetted, not going with default, understanding who has access to what. And actually there was a question here about what are the best practices to isolate containers for business critical. I think there's actually another piece of this that's kind of real-time detection and isolation of vulnerable workloads. So say, for example, there's a vulnerability that's detected. How do you act on that quickly? Because a lot of this stuff is faster than any of us can react, or a ticket has to get past that kind of thing. So getting into the habit of, or getting a process in place that like, hey, isolates a container or updates it or shuts it down or whatever it is, to make sure that you're limiting your blast radius, I think is also important.
Yeah. As part of that whole move, I know you guys talked about, and I guess I'll throw this to Alex since you brought it up, then everybody's got to assume some level of responsibility. But in my experience, when everybody's in charge, nobody's in charge. Basically, the developers say, this is too hard for me to figure out, somebody else should do it. The security team yells at the developers and say, we wouldn't have this problem in the first place. So how do I kind of make this a team sport?
You got me. So no, that's a really funny question, because it's, the answer is why I think the word whatever you want to call it, DevSecOps exists. It's the same concept of DevOps, where we're supposed to put developers and operators, the people that are or making developers the same people that operate the system. It's just adding security to the mix. And I think if you, in an ideal world, everybody had skin in the game and understood that it's not just one person's responsibility, it's everybody's responsibility to make sure it's secure, then, everybody kind of takes that on. But that's an ideal world. I think, what we're seeing in practice is, for example, we're Tenable, that again, big vulnerability management company. What we're seeing is a lot of our customers doing, the traditional vulnerability management teams are handling the vulnerability piece of it, but they're not the application developers. They're not the people running Kubernetes. And so, the side effect of doing that ends up being vulnerability gets spotted. They have to go tell the application team that it's vulnerable. The application team might say, hey, we've got we're running this version for a reason, or we've got a compensating control, or we're mitigating this way. But then the security people, the vulnerability people don't understand that it's not their thing. And so I think the closer people operate, the better it is and the less siloed it is. But I mean, I'm not telling anybody anything they don't already know. But I'm also kind of explaining nirvana. Otherwise, the other way you handle this is you have a tool that, or a tool chain that allows you to interface at every level where it makes sense. So for example, a developer, you might have a tool that interacts in GitHub or their source code repo and interacts with their command line tool, so they don't have to learn something new, but it'll tell them, hey, like, look, you've got this problem, go fix it. Or on the, maybe on the InfoSec side, having a little bit more context and understanding of how to communicate that back to the developer and say, hey, this is what you need to fix, but in their language and not in the security language. I think developing a common language would also be important there.
I think that's been part of the challenge. When I ran the State of the IAC survey last year, and then just wrapped it up here again this year. And when I look at the differences, people are finding drift. So drift is one source of misconfiguration, for instance. But they've improved dramatically on their ability to find it, but not to fix it. And I think that's the hard part, is fixing it. And if you look back even before cloud, when you talk about back when Fortify used to do a vulnerability report, and it was not misconfigurations back then, it was failure to patch, right? And when failure to patch was the biggest security concern, people could find it, but actually patching and fixing is hard, because when you fix one thing, it can break another. And understanding how things are connected and where is this going to cause problems somewhere else. And so I think that you've seen also a rise in platform engineering teams. Gartner did a report on that recently about the rise of platform engineering, because they're really supposed to be the ones that kind of vet this and create the best practice that can be copied and empower the developers then to go do their job and focus on writing new applications, instead of trying to figure out, is what I'm doing going to cause another problem further down the line?
All right, there is now a wealth of content to unpack here. So let's start with a couple of things here. But Robert, let me ask you, so many people don't patch. So many people are running outdated versions of Kubernetes, and then lo and behold, we're surprised when those things are attacked, because we left the instruction manual for how to attack them out there for cyber criminals. So naturally they followed it. We seem to be afraid to patch. Are we more afraid to patch in Kubernetes or update because we think the thing is going to crash? I mean, are we so scared of this platform that we're like, my God, don't touch anything? I mean, how do we kind of work through a cycle like that?
Yeah, I mean, I think it's less fear and more just it takes time and effort. And I think if you're not budgeting in a certain amount of time for your platform team or DevOps team or whoever it is to update Kubernetes, update any of the add-ons you're running, like Nginx Ingress or Cert Manager, if you're not budgeting that time for in every quarter, you're going to incur a lot of debt very quickly. Some of that's security debt, some of that's missing features, some of that's existing bugs that you're going to run into. So it gets very painful very quickly if you don't have enough time budgeted for those kinds of updates. And that's really every layer of the stack. It's Kubernetes itself. It's the add-ons you're running. It's the containers you're running inside of those for your applications, the root containers, the dependencies of your applications. Like there's just a whole lot of stuff that needs to be continuously maintained and kept up to date. Most of the time it's not that painful. Most of the time it's, bump the version and everything runs fine. But there is, maybe every 3 or 4 Kubernetes versions, they deprecate a whole bunch of APIs, and it does take, a concerted effort, to, the DevOps team figures out, okay, these are the things that are deprecated that we're still using. Maybe they make a list of everything, every team that's using these APIs. They have to contact each of those teams, tell them, hey, you need to update this manifest from this version to this version. Maybe that's just a simple one-line change. Maybe it involves something a little bit more complicated. And so it really helps to have some kind of platform or ticketing system or something like that in place that can help keep track of where you're behind in versioning. Have a list of, okay, these are the things that need to get moved up to date, and then prioritize that. So this is a critical vulnerability in this this version of Alpine. We need to get everybody up to this next version of Alpine as soon as possible. Versus we're on Kubernetes 125 and 126 is out. There's not really any critical vulnerabilities, but we know we need to do it in the next quarter. So let's get it done. So prioritizing those version updates, I think, is a big thing too.
Yeah, the other interesting thing that I think, and I completely agree with you on all the points you said. I mean, I think the Kubernetes has a lot of ability and capability around doing rolling patches and rolling updates and A/B testing that you could always do, but was much harder with cloud instances or, heaven forbid, on premise. But like, you can roll updates, you can direct 10% of your traffic to your patch side and the rest of it to your non-patch side until you make sure the patch side is ready. I mean, and I think with Kubernetes brought this, I don't know if everybody's familiar with pets versus cattle mentality, where like, we don't label our servers anymore with like, this is my Exchange server and this is my, like, I haven't seen a label on a data center in forever. If you treat it like a herd, essentially, like, or you don't do bespoke patching anymore. You do it. You bump a rev in a piece of code and say, hey, I'm going to run this, direct 10% to that, and you can be a lot faster and a lot more agile, with that framework than you ever could before. I do also want to touch like that platform engineering thing that you had mentioned, Cindy, is very important, because I think the platform engineering people can their job is to provide a platform for engineers to run this stuff on. If they put the sufficient amount of guardrails and the process behind this stuff, hopefully it's not, it makes it easier that you don't build as much tech debt. Because Robert, you're 100% right. Like, if you don't build in time as part of your process to make sure you're addressing this, we all know where that goes. It's just, you're never going to do it, and one day you're going to wake up with some bad news. So, yeah.
So, Cindy, has this become a circular argument for I should always use a curated instance of Kubernetes or a managed service of Kubernetes where somebody else is doing all that heavy lifting for me? But we still see a lot of folks out there that seem to want to download something and install it themselves. But am I essentially accepting a level of risk when I do that versus putting the weight on somebody else to manage all that for me?
Yeah, absolutely. If think about it from a medical standpoint. If you were having a surgery, would you want someone that's never done a bypass to do your bypass, or would you want someone that does it every day for lots of people? It's the same kind of thing. I think you want to go with the experts that are very adept at this. And I see people painting themselves into a corner with DIY. When I was with GitLab, people would do their own CI, roll their own, and it just was a long-term a disaster. And I see that from a cloud standpoint where I am now with Firefly. We help people manage their cloud, and people will say, well, we don't need governance and automation because we have everything locked down. Well, I bet that makes their developers real happy. I wonder what their retention's like. It's a careful balance. And Alex really had, it was 100% on point in terms of setting up guardrails, and let the experts, whether it's the platform engineers of your own or outside experts, the people that really know the implications of the choices that are made, and let them set up the guardrails and set up the processes so that everybody else can run faster and not have to worry with it.
Yeah. To that point, Robert, what prevents people from using a managed service? You guys are in that business. So my question becomes, what is keeping people up at night, per se?
Yeah, I think, the pros and cons to kind of like doing it yourself versus, finding a partner to really help you, either at a managed services type level where you've got human beings working with you, or, at a software level, using like EKS, GKE, stuff like that. I think a lot of companies think that they have customization needs that are really, they like to think of themselves as very special, and we have all this amazing technology, and we really need to customize every little bit of Kubernetes. And there are cases where that's true. If you're like Netflix scale, you should probably be running your own Kubernetes clusters. But for the vast majority of folks, you should be using at the very least GKE, EKS, some kind of managed control plane. You probably don't need to be configuring your control plane, specific for your organization. And I would say for most companies, using a managed service provider who can, carry pager for the control plane, or who can, we have 2 mics now. I think using a managed service provider, having experts in Kubernetes kind of on your side who can, basically really know kind of all the undifferentiated stuff that goes into running a Kubernetes cluster that isn't, part of, your value add as a business, isn't part of, what you do best. It really helps. And there's really, only so many ways to run an application in Kubernetes. It's, most companies don't need the level of customization that comes from, running your own control plane, or, doing all the fancy stuff that a lot of DevOps engineers want to do with Kubernetes.
Yeah, exactly. I think the cloud stuff is kind of an easy button. I think one of the funny things though with cloud is it solves for part of the problem, but it doesn't solve for all of it, because there's still a shared responsibility model. So I can go in there and provision a Kubernetes, EKS cluster in AWS, and still deploy a vulnerable container that I'm going to get owned on. And so, and Amazon would tell you, too bad, so sad. I mean, I think they'd probably be nicer about it than I am, but like, it's still on you to maintain and do that. And so, but removing the need to become a Kubernetes expert to deploy that cluster, I think is a big win, and call it training wheels or whatever. I mean, I don't want to manage a Kubernetes control plane myself. I run, our demo environment stuff, I run it in EKS, because I can just click a couple buttons and there you go. If I need to upgrade the cluster, I can click upgrade cluster and it'll roll the update. I was talking about earlier about rolling updates. It does a hitless upgrade. Like, I click the button, it brings up a new node, brings up my workload on the new node, shuts down the old node. There's a lot of really great capability there. So, but it doesn't fully remove it. So I think that's one of the things that I don't, I want people to think like, hey, we go to the cloud Kubernetes stuff and we're fine. It's not like that at all. It just solves for part of it. I mean, frankly, I could have a control plane wide open on the internet on GCP just as easy as on-prem.
Cindy, do you think this is going to force an issue? I think.
I'm sorry, it was garbled a little bit there. Do I think what?
Yeah. Cody, can you kill my second feed there? But there we go. All right, that's better, I think. Does all this force the issue for security, in terms of the sense that I am going to think what my role is for the internal IT team?
I think security's role changes, particularly in the cloud. It used to be just a matter of testing for vulnerabilities, whether, testing your application and having your firewall and having, configuring access. But now those are not physical things anymore, and they change constantly by nature. And so security needs to be much more adept at understanding cloud automation and all of the infrastructure automation that surrounds applications that is actually code. I don't know what happened to software-defined infrastructure. That term seems to have gone out of vogue, but it really is software-defined infrastructure. I mean, to Robert's point, using infrastructure as code can alleviate a lot of problems because it makes things more repeatable, and you can apply policies automatically, and you can capture versions, and you can control access, and you can roll back. All of those things that you can do with software, now you can do with infrastructure when you're using infrastructure as code. And I think we'll see a shift over time with security starting to be more involved in that and understanding that it's those settings and those configurations that are super important. I can have all my access controls in place and from a networking standpoint, and I can scan for vulnerabilities. But if someone changes a cloud configuration to allow escalated privileges or to open an S3 bucket or, what have you, then it doesn't matter.
All right. Robert, I'm still getting that echo. Let me see if I can fix
It sounds fine from here, actually.
Oh, all right, great. As we think this through, Robert, for a minute, we have a lot of questions in the audience that are related to networking and networking security. Are we overlooking the networking aspect of this because we're all focused on the software a little bit too much? And are there threats there that we need to think about?
Yeah, so at the networking layer, there is definitely some control you can put in place. So at kind of a high level for traffic entering your applications in your Kubernetes cluster, you can set up like a web application firewall to make sure that anything that looks like an attack just like stops before it even gets into your Kubernetes cluster, right? So that's definitely a good kind of first pass. But I think the more Kubernetes specific technology that folks should be looking at is network policy, which can really make sure that a particular workload in your cluster is separated network wise from any other workloads running in your cluster, or separated from the external internet. So you can make sure that this workload's never allowed to reach out to github.com and maybe download a script that it could then run inside the container. Maybe it's not allowed to download anything from the external internet. Maybe it's never allowed to upload anything to the external internet or accept any incoming connections from the internet. So you can isolate pods that way, both within the cluster. You can say, this pod is only allowed to talk to this other, or this workload's only allowed to talk to this other workload because that's its database and it never needs any other network connections. You could say this workload needs, to accept incoming network connections from anywhere because that's our, user-facing API. So you can really get fine-tuned with that. It's something I've seen, mainly more sophisticated companies deploy because it does. If you do like kind of a deny by default scenario, it kind of forces your engineers to think through what are all the possible network connections I might make, and list those out, which is just a whole other activity for developers to need to take on. But it is definitely a good way to isolate workloads and limit the blast radius of an attack. If one of those workloads does get compromised, it makes sure that it can't do things it's not supposed to do.
Alex, we have another question here related to threat modeling. Do we need to pay more attention to that in this space because of the inherent complexity?
So do we need to pay any more attention to threat modeling because of the complexity? I would say you always need to pay attention to it. I don't know. I'm trying to think if it's really, I think here's what I do know. Kubernetes is new to a lot of organizations. I mean, I like I've been doing it for a while personally, but even 5 years ago, I'm having the same conversations today where people are getting into Kubernetes for their first time. And I think because it's new by nature, it's more complicated. I don't personally feel like the threat modeling per se is more complicated. I think what makes it more complicated from a threat mapping or management part is the scale and also the velocity of it, because the velocity of Kubernetes is even faster than cloud. So I can deploy right now on my Kubernetes cluster, I can deploy an application in seconds. How do I stay ahead of that? How do I model that? Well, you can't. And so I think what you need to, and I wanted to kind of say this earlier, but I don't want to monopolize the whole thing. But I think there's an aspect of if you catch it early in the development and build cycle and then deploy it secure, that's better. And so if you threat model and understand what you're doing ahead of the deployment, which you can do, it reduces your likelihood of deploying something that's bad. So that's not just vulnerability scanning, it's also scanning YAML manifests, Helm charts, that kind of stuff before deployment to make sure, for example, like Robert was saying, you don't deploy root containers. Like there's lots of work that you can do ahead of time to prevent it. But I don't know if I'm answering the question. I'm just kind of dancing around it. I don't think that it's, I don't know. I don't think it's any more difficult. I think it's just new.
No. Cindy, I know you played around with AI and we got to the 39-minute mark without mentioning it, but will AI save us from ourselves here in the future? And what should we expect from all those algorithms?
AI can have a really big role here in many ways. And it already has started having a role when it comes to cloud management in particular, being able to get codify the infrastructure as code, being able to write new policies. So, Open Policy Agent is a popular policy framework that's very helpful, but it doesn't go quite far enough. So if you want to write a bespoke policy, you kind of have to know Rego code. But AI now does that. So, those are some of the low-hanging fruits. In fact, we came out with something called AIAC. We're using AI to write IAC, and it's got over 3,000 stars. It's open source. It's the low-hanging fruit. I think where it's going to go next, though, is we talked about the difficulty of remediation and about understanding the blast radius and context. I think AI will have great promise there in helping put all the pieces together to see things that you might not on your own connect the dots between, and then having remediation advice that is I think earlier we talked about having it for things for the actual user. So in a DevOps language for the DevOps user, and in a security language for the security persona, having them understand what is the remediation that's required. I think we've just scratched the surface of what AI can do here.
Yeah.
Yeah, I would say though, it's funny. I didn't spend a lot. I'm not an AI genius. I'm just gonna straight up tell you. I had to actually think long and hard about how AI could possibly affect Kubernetes. I'm like, that doesn't make any, I don't even know what that means. But I think that you're 100% right, Cindy. Like it can help take very large data sets, like what my cluster looks like, and distill it down into something that I can actually easily consume. The thing that was kind of the other side of that I was thinking about is it also gives that to our attacker. So like anybody that's on the offensive side of that, that makes it a lot scarier, because now they can do the same thing but to your environment. And if they're in your environment, it's even scarier, because it'll say, how can I get exfiltrate data from this pod out to AWS's S3 bucket or something, and it gives you exactly the commands to run. And I think then that kind of puts an attack in the hands of pretty much anybody at that point. I don't know, that maybe I'm being kind of alarmist there, but I kind of want to look at it from that perspective too. I think it's kind of funny, but I think there's a lot maybe to unpack around real-time defenses, real-time attack, automated defense kind of stuff, where it, hey, like this is an abnormal thing. Is it doing something that it's never done before? Like, Robert, you had mentioned reaching out to GitHub and doing a pull, like code, or maybe reaching out to a Docker hub and grabbing a new container, whatever that looks like, and saying, hey, you've never done that before, and today you are. Kind of unusual behavior analysis, if you will. Running past AI might be useful as well.
Yeah, I think that's a really good point, that attackers get to use the technology too. Now, I think the thing that I'm most excited about in terms of the recent developments in large language models is the ability to reduce toil. A lot of like keeping things up to date and managing security misconfigurations is toil. It's modifying a few fields in YAML and updating a version from V1 to V2, and then like making one tiny change into the spec that is required in that version update. And that's the stuff that large language models are great at. They can do those repeatable tasks over and over. They can just open up PRs for you. You click the button and merge it, and everything works. That's where I'm most excited, because I still spend a lot of my time, or my engineers' time, doing those tiny little toily updates. It's maybe a few hours a week. Nobody wants to do it. It gets left behind all the time, and I think AI can really help with that and help keep us kind of up to date and following best practices.
We have a question from the audience. They want to know more about what is the role of observability in terms of making these environments more secure. It kind of plugs into that AI conversation. But Cindy, you want to take a crack at that?
Yeah, I think we often associate observability with performance, but it certainly is impactful around security as well. And having tools that can see the broader picture, I think, is important, because security is very siloed. You know, we have tools for vulnerabilities. We have tools, well, and for even more granular within that, for container vulnerabilities, and for it's very difficult for someone to see that full picture. And so, again, going back to the state of the IAC survey that we just did, last year governance was the chief challenge. This year, visibility is, which is kind of interesting. And what went hand in hand with that is not only are more people using multi-cloud, but more people are using multiple infrastructure as code frameworks. So maybe you've got Helm, you've got Argo for, around Kubernetes, but maybe you've also got Terraform and Pulumi and CDK, and so it gets back to that complexity, and how do you see everything that you have and the state of it, and that can be very impactful for security. So having the tools that will give you the visibility, I think that's why I say I think the security people are going to pay more attention to the infrastructure as code side of things, and what I have in my cloud, and what I have as my orchestrators, than what they have in the past.
All right. Robert, we have another question here related to, there's a bunch of them along the same lines here, but is the issue Kubernetes itself, or is it the containers and software that runs on top of it? There's an assumption by developers that a container might only run for a few minutes, and who's going to find it? There's also the notion that we can jailbreak from those containers, and that's how the infrastructure becomes insecure, which I think you mentioned. But do we just need to clean up our containers more aggressively to prevent the environment itself from being compromised?
Yeah, I mean, it's kind of an all of the above issue, right? It's I think that's one of the things that makes these security discussions so hard, is that you can spend all your time focusing on one layer or one attack vector, and you leave this whole the window's open even though you've got 10 locks on the door. So you really have to be thinking about all these things. Keeping making sure containers are being cleaned up, keeping them up to date. It's a great way to put locks on the doors, but you need to make sure that Kubernetes itself is up to date, that your control plane's locked down. There's really no single thing to focus on that's going to handle all these questions.
All right. Alex, we have a question about penetration testing. Is this something we need to do differently in the land of Kubernetes, or and should it be scheduled on a fairly regular basis?
Yeah, I think it's like more of the same. Yes, you should. Now the question is, are you asking, should I be pen testing my Kubernetes cluster itself or the workloads? I don't know anybody. I'm sure people are pen testing Kubernetes, control planes. I'm sure it's happening. Of course it's happening, right? I would probably, I don't know a whole lot of that space. What I know more about is, more pen testing the application itself. And I would say you kind of treat it like you would any other workload at that point. Maybe the fix is slightly different, because maybe to lock it down, you just need to do, a change in the pod's configuration, or maybe it's an upgrade of the software itself. But, or maybe you put, I saw mention in the chat about web application firewalls, maybe you put a WAF in front of it, so you stop, I don't know, SQL injections, that kind of stuff. So I don't know if it's wholly different. Yeah, I don't think so.
Robert, any thoughts?
No, I think Alex covered it pretty well there. It is a it would be interesting to see, like, if companies are actually doing penetration testing on Kubernetes clusters. Like, I've not actually seen it in the wild. Like, as he was talking, I was kind of going through, like, what would that actually look like? It could be interesting. I think the interesting thing is that, like, at the control plane level, most sort of penetration testing would be looking at, like, insider threats. So it's probably something like a big company would maybe want to make sure, their developers can't, they're going to get a certain set of permissions, and they can't do something that, like, only an SRE should be able to do, or something like that. It's an interesting question.
All right, guys. Start with Cindy. What's your best advice to folks then as we kind of look at all this, and what should they be doing to kind of get to the right result? Because, well, planning is everything, right?
Sure. I think not losing sight of the forest for the trees, really stepping back and understanding your overall governance practices and policies and the automation of that governance. This environment just moves too fast to rely on manual or periodic elements. I mean, Alex brought up a really good point that the attackers can use AI. Well, just because your Kubernetes cluster spins up and spins down rapidly doesn't mean that there's not time for an attacker to get in there with something automated and do malicious things. So really looking at it more from a process standpoint and governance standpoint, I think is really key.
Alex, thoughts?
Yeah, I think there's a lot of things. I think fixing. If I were to be prescriptive about it, fix your vulnerabilities. Lock down access laterally, like Robert was saying. Like if something should talk to it, then let it talk. If it shouldn't talk, don't let it talk. If you've got you like I mentioned before, if you've got a registry that contains all your blessed images that you've scanned that are known good, which by the way might take of your ephemeral workloads, because if they're just popping up, popping down, the way you stop it is your gold image, not scanning it when it comes up. It's you have to do it very quickly, and so deploying it right before you deploy it, and knowing you're deploying it right before you deploy it is the right. So that's kind of a shift left application of security. Not going with defaults, making sure you're looking at stuff. RBAC. I think Robert, you had mentioned like making sure that internally teams can't do things like, for example, a classic one is requiring somebody with the right permissions to open an application to the internet. I see companies do that, where only AppSec people or somebody can actually go in there and expose it. Your developer can't. So making sure that you have things locked down to the point like you would with on-premise. Like again, don't necessarily, the method might be different, but what I'm trying to say is it's not necessarily any that categorically different in the thought process. You don't expose things that you shouldn't expose. Understanding who has access to what, and not just people too. It's machine identities and understanding like, a lot of the breaches that happen are because the actual machine itself that got breached has access to something that it shouldn't, not just a person that had access to something they shouldn't. And so, I just throw those out there.
All right. Robert, we have a question about, well, what are the top container vulnerabilities to look for? What should I be scanning for? Because some folks are just basically, help me get to the basics so that I can fight the fight from there.
Yeah, so I mean, there's really two things you should take into account here. One is just kind of like automated scanning for known vulnerabilities, right? So there are open source scanners like Trivy out there where you just point it at a container image. It will look at all the software that's on there and say, you're running this version of PHP, which is known to be vulnerable. You've got this, this OpenSSL version, which is known to be vulnerable. It will tell you whether it's a critical vulnerability or a low vulnerability. It'll tell you, what version you need to update to fix that. And so just making sure you're scanning for those known vulnerabilities is a great start. Making sure you're fixing the critical ones. And then also along that same line, making sure that, you're keeping your containers as small as possible. So, rather than building on Ubuntu and installing all the software in the world on top of it, really, start with an Alpine image or build from scratch if you can, and just like stick a binary on it. That's going to just reduce the attack surface. It's going to reduce the amount of toil you need to do to stay updated. But it's really, it's hard to say that, look for these 5 vulnerabilities. Every now and then you hear like a really big one, like Log4j was a huge one that everybody was really panicked about. And you could use Trivy to like scan and make sure you didn't have Log4j installed at a vulnerable version. But there's really, thousands and thousands of them, which is what makes this so hard. The attackers have the list of, these are the versions of PHP that are vulnerable. I'm going to snoop for these versions of PHP. And if you're running it, I'm going to attack you. And so it's really a matter of doing that kind of automation to make sure you're looking at these thousands or, maybe probably like hundreds of thousands of vulnerabilities that are out there.
All right. We have a couple of questions on the following topic. I'm going to kick it to Alex, but feel free to jump in. Are there security features built into Kubernetes that people should be taking more advantage of? And is there anything on the roadmap that you're aware of that you're looking forward to?
Well, that's a good question. So the answer is that Kubernetes in itself is an orchestration framework, right? So the reason why I'm saying that again is because the keyword there is framework. It's not a finished solution, right? And so you actually do need to do things in order to secure it. So yes, can you do RBAC with Kubernetes natively? Absolutely, you can. How do you tie that into your authentication authorization system is up to you, and you have to extend that. And so that's one example of many where yes, there's the framework to do it, but you have to also build it. And that's the allure again of cloud security or cloud provider provided Kubernetes clusters is, for example, in AWS, I can integrate AWS's EKS service with AWS RBAC and then say, hey, this AWS user has access to do these things. This user can't. And so you kind of have to build it. You can't just rely on it. Otherwise, what would happen is you could run applications in Kubernetes. Your RBAC might be cool, but you'd still be missing a bunch of services anyway. Like you wouldn't have backups, you wouldn't have persistent disks, you wouldn't have an ingress, you wouldn't have all this stuff. And so you still have to build it. Yes, you have to build security around it. So provide you a framework, but doesn't do it for you.
All right. Robert, you want to add to anything?
No, I mean, I think Alex hit the main points, but it's RBAC, it's network policy, it's container security are the big things that you should be. Those are probably the three big check boxes of Kubernetes features you should be taking advantage of.
All right, last question. We'll go to Cindy now. Here's the question for you, Cindy, and we only have 2 minutes. So, what's that thing you see people doing over and over again when it comes to Kubernetes security that just makes you shake your head and go, folks, we need to be better than that?
I think assuming that in that shared security model with the cloud, that the cloud provider does way more for you than what you need to do. I still shake my head over that. I wrote a book back in 2018 for O'Reilly, and it was based on my experience of going to RSA and listening to what people were asking about container security. Oh, container, it must be a physical thing. I should be able to just set up my network security against it, right? And like, no, you don't understand. And I think people still don't really give it the effort that it should get. So oversimplifying and not paying attention to this very topic. So I'm glad that you're doing this topic today, Mike.
All right, there you go, folks. We could go on forever about this, but I'm going to kick it back to Cody. He's going to take us out.
All right. Thank you, Mike. And Cindy, Alex, Robert, thank you all so much for joining us today on Techstrong Learning. It's been such a pleasure.
Thanks for having us.
So before I release everyone, a couple of final reminders. Our session today was recorded, and we'll be sending you an email with the link to access this recording. So look out for that shortly. You can also find it living on the Cloud Native Now website. That's cloudnativenow.com/webinars. As a reminder, we'll be sending 2 $50 Amazon gift cards to 2 of our most engaged attendees today. So thank you for your chats and for your questions. You'll notice at the top of the chat, there is a link to our webinar survey that we'd love for you to fill out. It's also in the handouts. Filling that out will qualify you for that gift card giveaway as well. So once again, I'd like to thank our panel, and to our audience, thank you so much for attending today. We appreciate you spending time with us here at Techstrong Learning, and we hope to see you at a future learning experience. Have a great rest of your day, and you may now disconnect.